Preethi, Assistant Professor from the Department of Computer Science and Engineering. Today, our topic of discussion is project scheduling. So what exactly do we discuss in project scheduling? That is, priorly we have to list out the tasks that are involved in executing a project, that is, differentiate them into various minor units and try to allot some people in that particular area, then try to execute the things and monitor them, try to manage the risks and update on a timely basis. So all these things mentioned will be discussed in the today's topic, that is project scheduling. So let's start our today's discussion. The first thing that we are going to cover is project scheduling. So under the project scheduling, we'll be focusing on the basic principles of project scheduling and the relationship between the people and the effort. The people and the effort meaning how many people are involved in a project and how much task is given to each individual, how is it calculated, monitored, and what is the effort that is obtained. So this will be discussed in the relationship between the people and the effort. Next is the effort distribution. So people are involving in some efforts. Now, how are those efforts being distributed in the entire life cycle of the project? Will be discussed under the effort distribution. Next is the earned value analysis. In short, is also termed as EVA. Here, once the schedule has been set, how are you trying to monitor the things that are scheduled? Trying to give an analysis of the things that have been stated in a project will be discussed under earned value analysis. So I repeat, our today's discussion will include project scheduling, the basic principles of project scheduling, the relationship between the people and the effort distribution. The second major topic is the effort distribution and the earned value analysis. Now, what exactly do we discuss, or what are the things that you need to learn under project scheduling is the reality of a technical project, which involves various small tasks that must occur to accomplish a larger goal. So what is the main goal or main motive of scheduling a project? Is that we are supposed to consider a technical project that is in reality, meaning the real world applications, right? Whatever we see every day, right? Facebook, Twitter, WhatsApp, Telegram, all these things are various applications where people work every now and then, right? Every morning we open to see what are the things that are stated in our family groups, friend groups, the organizations. We need to check out all this. So there are many real-time applications which people use every minute, or in the other terms, I can say every second as well. So how are those projects scheduled background? So the reality of those technical projects. So this technical project will involve lots of smaller tasks. It can be hundreds, thousands, and many more tasks that are combined together, merged together to achieve a goal. So the major focus is you're involving a project that has various tasks and it needs to accomplish a goal. The goal has to be achieved. Next, the main objective for a project manager, right? Why do you have to discuss about project manager is that he is a person who has a whole and sole responsibility of a technical project, who knows about the groundwork that is there about the project, or who knows exactly what documentation is involved in a project. So the main objective or the goals of a project manager, you can see it defines all the project related tasks. So the project manager's first objective is to define various processes or tasks that are involved. Next, once all these tasks are described or defined, he has to build a network that will depict their interdependencies. So once the first major task is he has to define tasks involved in the project, then form a network that are merging all these tasks together, and they are trying to give us a interdependency relationship. Next, identify the tasks that are critical within the network. So initially he will have to define the tasks, then he has to form a network or build a network, then he has to focus on the critical things that are happening within a network or arise during the process. So the next thing is, once he has defined all these and done all these things, he is supposed to track the progress of the work that has been done up till that particular point. To process all the things that have been scheduled, we need a schedule that will allow us to monitor the project and control the project. So these are the major things that a project manager has to do. Define the tasks, build a network for all these tasks or merge all these tasks together, and also has to know about the critical things that happen within the defined tasks. Try to track their progress, know the risks, track their progress, and this progress has to be monitored and controlled throughout, so that at the end he is not having much of difficulty in to find out the effort of the people or the project's effort. Right. So moving to the continuation of the project scheduling. Software project scheduling distributes estimated effort across the planned project. So I have just stated few things, that defining a task, forming a network, trying to know the critical issues within a network, and trying to have a complete monitor or check on the tasks that have been defined every now and then. Right. Now, what happens here? The software project scheduling is trying to distribute the estimated effort throughout the planned project. So whatever tasks have been planned in a project, there is a effort that is being distributed to each and every task involving people as well. And this schedule evolves over time. That is, every task that is being executed is having a check, and throughout the process, every unit that is being executed is having a monitor or check through the time. In how much time are we able to execute this particular process or that particular unit. Next. So during the early stages of project planning, there is something called macroscopic schedule that is developed. Meaning, whenever you are initial stages of your work, you plan, right? Suppose we have some tasks or we have some work ahead. So we plan out the things today. So whenever you are trying to initially plan something, you make a just very normal way what has to be done at what time and all these. So that is called a macroscopic schedule is being developed at the early stages itself. That can change basing upon the changes in the movements happening by the people and their effort as well. So during the early stages, we just schedule a macroscopic schedule. Now, what does this do? This type of schedule is trying to identify major process framework activities and the product functions. So whenever you are trying to build a rough schedule or a macroscopic schedule, it is trying to give you a proper focus on the process frameworks, right? We have discussed in our previous videos regarding the framework activities, that is planning, communication, maintenance, construction, and deployment. So whenever you are trying to define a macroscopic schedule, it is trying to focus or identify the major process frameworks in our product functions. Next. So moving further, we are looking at the scheduling concepts in two notions or two different perspectives, right? Scheduling a software engineering projects is based upon two different perspectives, or we are having two different notions of it. So what is the first one trying to tell us? In the first one, the end date for release computer-based system has already been set. So what is the first notion or first perspective trying to state? That the end date of release of whatever work you have to do is already set, right? And the software organization is also reserved in the sense it is also given the effort and the prescribed time frame. So in the first notion, your end date for release of your project is already fixed, and the software organization is also reserving the distributed effort and within how much time frame. So in short, you can say you have the end date already being fixed, and how much of effort has to be distributed within what time is also fixed in the first perspective, right? So in the second, what happens? In second view of the software schedule assumes that there is a chronological bounds that have been discussed, but the end date is set by the software engineering organizations. So in the first go, there is an end date that is actually fixed, and there is some amount that is being focused on the distributed effort and within what time. All these things are fixed in the first notion. In the second notion, what happens is there are some assumes, or in the software scheduling, there is some rough chronological bounds that have been discussed, but the end date is set. So there, it means that you can change. Since there are so many things that are roughly stated, there are chances of changing the end date as well. So moving to the next topic, that is the basic principles under the project scheduling. So up till here, it ends what exactly is the introduction to project scheduling. So here we focus on what are the basic principles of project scheduling. First one, compartmentalization. Compartmentalization. So the name itself, when you just break up compartmentalization, that is, you're trying to break them down into modules or less amount of tasks. The project here must be divided into number of manageable activities and tasks. So the first point tells that whatever project you take up, that has to be divided into different activities and the tasks. So to achieve this particular principle, you are supposed to refine both the process and the product, right? Refinement has to be involved for both these things. Next, interdependency, right? The name itself is saying it is being interdependent. Okay, so what does this mean? Whatever we have stated and compartmentalized, that is, you're trying to break them out into different modules and trying to refine them in both the terminologies, that is the product and the process. So when coming to that second principle, that is the interdependency, you are trying to take each compartmentalized activity, that is each activity that has been divided. So we apply this second principle to the first one, you can say in the other terms. The interdependency of each compartmentalized activity must be determined. So the first go is trying to tell us you are dividing the things into various activities and tasks. Interdependency is trying to tell that whatever you have divided, try to check upon what is that each activity giving us. How are the activities involved how is it independent in the other terms? And few tasks will occur in sequence. Even though they are coming under the principle of interdependency, they are trying to, they will or sometimes involve in a proper sequence, which can occur in parallel. Some activities cannot commence, that is, whatever activities have been divided, sometimes will not be able to start. When are they not able to start? Until the work product produced by another is available. Meaning, as I told you in the previous point, some tasks follow a proper sequence. Right. So one of the tasks, if it is not able to start, meaning either it has not got the connection task to it or something which is not stated prior to it. That time it is not able to start. It means that the last point. Right. Other activities can occur independently. If they don't have any relationship within the prior activities or the other later activities, they can start independently. Only those activities which have a connection to prior and later tasks have to wait until they are defined. Moving to the next principle, that is time allocation, right? The name is as simple as it's stating, time allocation. That is trying to allocate time to different tasks that have been divided into. So each task to be scheduled must be allocated some number of work units, meaning task number 1 XYZ time, task number 2 ABC time, like that. Each task will be scheduled with some amount of time. Each task also must be given the schedule in times of start date and the end date as well. Start date and the completion date, which are acting as function of interdependencies, right? So time allocation is nothing but trying to, whatever activities we have broken down, each activity must be defined within a time frame, or it must be executed within that much amount of time. And you also, each task also must be assigned a start date and a completion date, which is acting as a function of independencies. That is, interdependencies, meaning there are 5 tasks. The first task has been started today, right? And the second task, once the first is over, the second will take another 2 days to start. So it is like acting as a function of interdependencies. When one is done, it moves to 2, so on up till the 5. So that follows the principle of function of interdependencies. Next, whether work will be conducted on a full-time or a part-time basis. You also have to know how many tasks are coming under the category of part-time and how many tasks are coming under the category of full-time. So that assessment and schedule has to be done priorly, because there are some small tasks which do not require more amount of time or the working days. So wherein they can be put under the slot of the part-time. And if there are some activities which are taking a really long time or need to refer the tasks priorly, on prior basis or the later basis, they will take more amount of time, which fall under the category of full-time basis. Next principle is the effort validation. So we have been discussing, trying to focus on the project, trying to break down the project into different tasks, people involved in executing those tasks, trying to allot time for them. Now, how much effort is being applied by all these things that have been stated? So you are trying to validate them in terms of the effort they have put into. So this principle is trying to elaborate that. Effort validation. What does that do? Every project has a defined number of people, right? Every project will have some amount of people or few people involved in it, right? They are also termed as the software team, people involved in a software team, right? As time allocation occurs, we have to focus on one particular thing, that is, no more than allocated number of the people have been scheduled at any given time. So this second point under the category of effort validation states that you have been allocated some time for some people to execute their things. You should not involve other people at any given time in the process. It tries to disturb the work, or there are some clashes, or the project execution in the way it was planned, it might not execute and results in the different kinds of flaws. So moving to the next principle, that is defined responsibilities, right? Defined responsibilities, they're nothing but duties that have to be accomplished by the people in the project. So they are having some responsibilities that are already stated to them that they have to do within the project. So every task that is scheduled should be assigned to a specific team member, right? As all of us know, when people working in a software company, they work under various projects. Each project has a team lead. Under team lead, there are so many team members involved, right? So if we are talking about the team members, one of the person also has to be allocated as the main member of the team, so that he will know the schedule exactly. Else the things become very clumsy. The first point is trying to state that every task that is scheduled should be assigned to a team member. Next, defined outcomes. So what are the results? Outcomes are nothing but results. What are the defined outcomes? Every task, whatever you have been scheduled, must have a defined outcome, meaning you should priorly know that this is the output. As simple as our research project. So priorly we assume that whenever you are trying to send these things as inputs, right, to some tools that we are working on, this will give us some this will give us this expected output, right? We make our students write expected outputs as well in their programming labs, right? The result may be partly or completely differing, but we just ask them to write the expected outcomes first, so that when they're trying to execute, they can match the things. So priorly, before you do any type of task, you have to define the outcomes. Every task that is scheduled should have a defined outcome. Next, for software projects, that outcome is normally a work, meaning whatever they're doing, they're expecting to get something out of it, which is called the work. And the work products here are combined in deliverables, meaning you break them down, try in units. Each unit is being executed and then put forward. Second task is being executed, put forward. Third task is being executed and put forward. At the end, you try to merge up all these things. So work products are often combined in deliverables. Next principle of scheduling is defined milestones. Milestones are the checkpoints or your goal that has to be accomplished in certain amount of time. So defined milestones. Every task or group of tasks should be associated, meaning whatever you are stating, let it be an individual work or a team of activities, a group of activities, they have to be linked up or associated. That is, defined milestone principle follows this. Next, with a project milestone. A milestone is reached when one or more work products have been reviewed for quality. As I just told you, whenever you are, let me take an example. Whenever you are trying to draw a picture of a scenery, what do? You look at the image, try to put some points, right? Some pixels, you just try to put it on a paper, then try to start drawing by looking at the image, trying to finish it from left side or right side, from the top or the bottom, right? And then you check, okay, these are exactly fine. And now let me trace it in a darker way and then add on some colors to it. So it is like, my drawing was divided into 3 milestones. So every milestone I keep a check upon, right? On how my quality is. So once I just put dots, it's my first milestone. Next, I try to draw a rough sketch is my second milestone. Then third, I try to finish it and then color it. So 3 to 4 milestones have been defined for my task. In the same way, when you are trying to plan out something in scheduling, it must be reached when one or more work products have been reviewed for quality. So that is simply to have check, process executed, and try to have a check on the quality. And it also has to be approved. So each of these principles is applied as a project schedule evolves. Meaning, whenever you are trying to focus upon project scheduling, all the above stated principles have to be implemented or try to have a complete check upon. Next, our next topic is the relationship between the people and the effort. Right? So we can see a diagram that is trying to have a focus on the development time. That is trying to have a focus on the development time on the x-axis, you can say, and on the y-axis we have effort cost. Okay, so the x-axis is trying to focus and trying to talk about the parameters that involves TD, T naught, and it also has E naught and ED. So this ranges, that is, why is this in the region of impossible region, and what happens when you exceed that T minimum 0.75 TD, we will be just discussing. So first, the relationship between the people and the effort. So to understand how many people are involved in the project and how much effort is being delivered by group of people per day, per month, all that is calculated with this in this particular area. So in a small software development project, a single person can analyze the requirements, perform design, generate the code, and conduct the test. So to understand the relationship between these two terms, that is the people and the effort, we just have to first tell about what happens for a smaller software, what happens for a large software. So whenever you talk about the smaller software, you are trying to analyze requirements first. Next, perform the design, generating the code and conducting a test. So whenever you want to start off, we first define requirements or the steps, as all of us know, and then try to form a design or a model basing upon those requirements. Once the model is ready, try to write the code and bring out the code out of it, and try to perform some different types of testing, as we know, unit testing, system testing, integration testing on all these things that have been coded, right? The second point, as the size of the project increases. So initially we have spoken that for a small software development project, what happens? These are the things that have to be analyzed. That is requirements, the design, code, and the testing. But as the size of the project increases, more people must be involved, right? More people must be involved because the size of the project is increasing. Here comes, why do you have to know the relationship between the effort and the delivery time, right? So if the software would have been small, the focus of both these things would have been normal. But as the size of the software keeps on increasing, there comes a check on the relationship between the effort and the delivery time, right? So looking at the graph over here, you can calculate EA, that is effort in the persons per month, is calculated by M cross, that is M product of TD to the power 4 by TA to the power of 4. Now what is TD? It's the normal delivery time. And what is TA? It's the actually delivery time. Okay. And you have T naught as well. That is T naught. The O stands for optimal. Optimal development time, that is basing upon the cost. Right. Moving to the further things on how this relationship goes on can be described by one common myth stated, that is, many managers who are responsible for software development projects have a idea, or not exactly an idea, they think. What is that myth? Is nothing but whenever we fall behind the schedule, we can always add more programmers who will be involved later part in the project. This is a common myth where all the managers try to think upon. So what is it? It is nothing but whenever you fall behind the schedule, as I told you, as we have discussed various things in project scheduling, that we have to have a proper schedule. So what is he telling here is, if you must if you fall behind the schedule, what people actually think is you can add more programmers to catch up later in the project. But here, when you are trying to do this particular thing, you also have to have a check, that is this particular one. If you must add people later in the project, be sure to assign them work which is highly compartmentalized, right? This was our first principle in the project scheduling. What did this state? Compartmentalized, trying to break the activities down into different tasks and giving it to different people. So whenever you are trying to add people to the existing project which is running out of the time, you also have to see to it that their work is highly compartmentalized so that they can execute the things in a much better way, right? And there is this person named Putnam Norton Relay curve. Whatever you have seen in the front, it's a curve that is named as PNRC. PNRC. Putnam Norton Relay curve. Fine. This is trying to show you, or it provides an indication for the relationship between effort applied and the delivery time in a software process. So how many people are trying to apply their work in terms of effort, and in how much time are they trying to do it? So this relationship is being called as the Putnam Norton Relay curve. So moving further, a version of a curve representing the project effort as a function of delivery time is shown above. So whatever graph we have seen, it is like, as we have just shown you, it is a relationship between the effort and the time that is being delivered. Okay. Now, looking at this particular point, the curve, whatever is there, is indicating the minimum value to indicates the least cost for the delivery. So the curve that is being shown above is trying to state the minimum value. So minimum value to the cost needed for the delivery. And that delivery time will result in the least effort that is being expended. And as we move left of the T naught, right? When we just have a look at this particular graph, that is the T naught, whenever you're trying to move to the left, it is trying to say that it is trying to accelerate the delivery. That is, the curve is trying to increase in a non-linear fashion. Now, a project team has been estimated a ED, that is level of effort that will be required to achieve that in the normal delivery time. So I repeat, whatever the project team is involved in the effort and the delivery time. So the effort is termed as ED and the delivery time is termed as TD. Okay, and it will give us the optimal results whenever you are having some available resources with you. So whenever available resources is there, then we can have a proper relationship between the effort that is being put and in the time period that it is being obtained. Fine. Now, it is also possible to accelerate the delivery. The curve very sharply moves to the left. So if you want to deliver it on a faster pace, right, the TD value is trying to get adjusted towards the left side. And there are some things what this PNR curve is trying to indicate for the project delivery. Okay, it says that if you are trying to compress much beyond this, then what happens is you can do up till 0.75 TD as it's mentioned, the curve can go up till there. But if you're trying to compress more than this particular value, that time there is a impossible region that exists which will cause a risk and the failure rate is too high. So again, from the initial ways, you have to change the values and do all the things all over again. So as you are trying to compress more, it becomes too risky and the failure rate is also too high. Next, the PNR curve shows the lowest cost to be T naught equal to 2 times of TD. That is, the optimal time is 2 times of the delivery time. And the implication here, whatever is stating, is delaying the project and can reduce the cost significantly. So whenever you are trying to delay the project, the cost also keeps on reducing significantly. So finally, this must be weighted against the business cost associated with the delay, meaning whatever the things are you have stated, try to give them a proper effort and some time specified to it. If it is trying to show different kind of delays, then there will be reduce in the cost as well. Okay. Next. Now, here this is a very important equation that is trying to show the L. That is the number of delivered lines of code, which are also in the other terms are called as source statements. So this L stands for the lines of code, which is giving us a formula as P cross E to the power of 1 by 3 into T to the power of 4 by 3, where E stands for the effort by the people in 1 month, 2 months, person per month. Okay, and P is nothing but the productivity parameter. How much is he trying to produce or finish a quality work? And T stands for the duration of the time that he has taken during the execution of the project. So this is the formula where you calculate the number of delivered lines of code using P, E and T. E stands for the effort by the people in months. P stands for the productivity parameter and T stands for the time duration that it takes. And trying to look into more factors in the relationship between the people and the effort. Here you can see, rearranging the same software equation, you can arrive at the effort. That effort is nothing but L to the power of 3, that is lines of code, or how many lines of codes are there, by the product of P cube to T cube. P is the productivity and T is the time taken, where E is the effort, as I have told you, in the entire life cycle and life cycle process, and T is the development time it takes in years. So moving to the next category under the project scheduling is the effort distribution. As I told you, whenever you are defining a project, you are having various tasks. Various tasks are involved by the people. How much time are they taking to execute the things? And how is the effort being applied on them? And how is this effort being distributed? So how is it being distributed? Is how should effort be distributed across the software process workflow? So there are some things that have been defined or have been stated. How do you distribute the effort? So let us see how the things have been distributed. Firstly, effort distribution should be used as a guideline only. That is, complete focus or complete check on effort must not be done. It is just like a guideline only. Okay, so whatever characteristics that each project will tell us will talk about the distribution of the effort. So I repeat, effort distribution is only a guideline, or it is just trying to state something. Okay, you cannot have a complete check on the distribution of effort. Whatever characteristics you're stating for a project, that will also talk about the distribution of the effort. Okay, right. So what is it saying is, work that is planned in a project rarely accounts for 2 to 3% of effort. 2 to 3% of effort that is being involved in a project, right? Unless this plan commits an organization to large expenditures, it leads to risk. Okay, so on what things should you focus the effort distribution? Firstly, you should think that it is acting only as a guideline. Second is, whatever characteristics that you have stated will talk about the distribution of the effort, and this can lead up to 2 to 3% of whatever you are trying to talk. Unless you have large expenditures, then it will lead to some kind of risk. Next, here the customer and the requirement analysis will try to comprise how much of the effort? 10 to 25% of the effort. So when you say customer communication and requirement analysis, so customer communication meaning the way, how much inputs are you taking from the customer? How does he expect you to build an application? Okay, what are the requirement analysis that have to be done on the inputs you have taken from the customer? All this requires how much effort? 10 to 25% of effort. And this effort expended on analysis or prototyping. So whenever you are trying to concentrate or analyze the effort, it will increase directly with the size and the complexity. So I repeat, whenever you are trying to take the inputs from the customer or trying to talk to him, trying to take the requirements, trying to focus on the requirement analysis, it is trying to take up to 10 to 25% of the effort distribution, right? And how much effort you put into it leads to the, it is direct increase or it is directly proportional to the project size and the complexity. Next, design. Once all the things are stated, we are supposed to design or model the things, which takes up to 20 to 25% of the effort, right? And then you are reviewing the design and trying to subsequent iterations that are required or trying to have something added up to it. All that is being focused, right? And our next topic is earned value analysis. In short, it is called as EVA. Now, what is this trying to give us, or what is it trying to provide? It is trying to provide a quantitative indication of progress, meaning how is our progress being monitored, is trying to give by this particular expression, that is EV. Earned value is nothing but how is our progress being monitored. So to elaborate that in a more better way, you can say that a number of qualitative approaches to project tracking exist. Meaning, if you are trying to track a particular project, what are your qualitative approaches? Meaning, whether you have reached your milestone or not, is the first point. Next, Each one provided by the project manager is trying to indicate the progress. So what you have to focus is that whatever the project manager, in our initial slides we have discussed the objectives of project manager. So whatever he has stated, that also keeps a check on whether how your work is being progressed. Next, but whatever we have stated, that is having a check on the milestones, have to monitoring all these things, is it done in a subjective way? But if you want an assessment of the information provided in a subjective way, so it is reasonable to ask whether there is a quantitative technique. Okay, that to elaborate that in a quantitative technique or having a quantitative technique, there comes the existence of EVA, that is earned value analysis, that is trying to show you the indication of our progress. Okay, and there is a person named Humphrey who is trying to talk about the earned value in this manner. So what exactly is he trying to tell? He is trying to say that it is trying to provide you a value or a common measure of what the software project is, and irrespective of your modules, your tasks, your activities. The main motive of what earned value system is trying to tell you is, it is trying to tell you about a common value of your project irrespective of your activities, and what are the total hours needed for the entire project are estimated. Okay, and every task is having a earned value, and at the end you are trying to merge up all these things. So how this all works, let us have a look at it. How do I compute earned value and use it to assess progress? So earned value is trying to show you the indication for our progression. Now how are you able to do it? So how do I compute earned value and use it to assess my progress? So firstly, you should know about this BCWS. It is elaborated as budgeted cost of work scheduled. So for whatever work that is being scheduled, you have some cost associated with it. That is called as BCWS. Now, this BCWS is focusing on every work task, that is I. So you can say that BCWS is the effort plan for work task I, meaning for every task of I, you are having a cost that is being defined. So whenever you are trying to sum up all these budgeted cost work schedules for all tasks K, that is for how many ever tasks you have, if you are trying to sum up all those, that is you are trying to merge all these individual tasks together, so on. Okay, and they all are considered as the K tasks. Now you have something called BAC over here, that is nothing but budget at completion. So at the end, what is your budgeted cost? How are you calculating the budgeted cost? It is the summation of all the tasks that are involved, that is summing up of each and every individual task. Right. Next, we have BCWP, that is budgeted cost of work performed. Right. So budgeted cost for the work performed is the sum of all the BCWS values. When will you say that the work performed is achieved? When you are trying to merge each and every individual tasks together. That is, you are summing up all the work schedules together. Next, and there are some values for all these things which focus on this SPI, that is Scheduled Performance Index. So this SPI is calculated by budgeted cost work performed to BCWS, which is nothing but budgeted cost work scheduled. So I repeat, SPI is equated to the budgeted cost work performed by budgeted cost work that is scheduled. It helps you to find out the index, performance index. So meaning, what is your total work? How much have you performed? So the that particular this statement gives us how much is your performance index. Now to know the variance, to calculate the variance, you are supposed to find out the difference between these two things. That is SV equal to BCWP minus BC WS, that is budget cost work performed minus budget cost work schedule. And what is this trying to indicate? What is this SPI trying to indicate? It is trying to indicate, telling us that how much of project is being utilized from the resources that are available. If your value is close to this 10.0, then efficient execution will happen, right? And is simply an absolute indication of the variance. And you can also state that percent schedule for completion is nothing but budget cost work scheduled by the budgeted cost, BAC. In again the time interval, focus on the time. How much ever is completed, you will calculate it in this manner. Fine. Next you have something called ACWP, that is actual cost. What is the actual cost? Here we are talking about the budgeted cost, but what exactly is the actual cost? You can calculate the value of this by summing up all the efforts. So you can compute it in these two ways. Cost performance index is CPI, which is calculated by BCWP by ACWP, that is budgeted cost work by this actual cost. And variance also can be obtained by their differences. CV equal to BCWP minus ACWP. This again, it indicates within the budget 1.0, and you have CV is an absolute indication for the cost savings. It illustrates you the EVA. So finally, what is it telling you about this EVA? It is trying to tell that it is also focusing on how much you have to remove the scheduling difficulties before it is brought into the picture. And this also enables you to make or observe the project crisis. Okay, all this earned value analysis is trying to keep a check on the scheduling difficulties, first one. And if you are trying to reach some project crisis, how are you able to remove them with the help of these costs is also helped by this EVA. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.